Hi kids, in today's video we are going to discuss surface area and volume of solids from class 9. Now, the first thing we should know is what do you mean by a solid? Very simple. A figure which occupies a portion of space enclosed by plane or curved surface is known as a solid figure. If you see a cube, a dice, that's bounded, that figure is a solid figure bounded by plane surface. But if you see a football, that's bounded by curved surface. So both are solid figures, isn't it? And solid figures, we know, have three dimensions, basically length, breadth, and height. And what do you mean by volume? The amount of space occupied by a solid is known as volume, whose unit is cubic unit, isn't it? So volume is the amount of space occupied by the solid. For example, you've seen, if you take a shoebox, a shoebox is bounded by rectangular faces, and the amount of space it occupies is known as the volume. How much space it has occupied, that's known as the volume occupied by the cuboid. This is a cuboid, isn't it? Now, so solid is clear. And what do you mean by volume? Surface area. Now when you talk about a surface area of a solid, we mean the sum of areas occupied by the plane or curved faces of a solid is known as total surface area, is known as TSA. I'm writing total surface area. For example, if you see this cuboid, this has 6 faces, so sum of areas of all the 6 faces is known as TSA. A1, A2, A3. In this case, I'm talking about A4, A5, A6, because you see there are 6 faces. Am I clear or not? Now let us discuss cuboid and cube separately. Now let us talk about a cuboid. So cuboid, in simple, we can say a solid figure composed of 6 rectangular faces, isn't it? That's a solid. You've seen a box, it looks like a cuboid, isn't it? I'll just try to draw a cuboid. Now, just look. So, if you look carefully, there are 6 faces of a cuboid. Okay, the corners 1, 2, 3, 4, 5, 6, 7, 8. These corners are known as vertices, and there are 18 numbers. And the 6 faces, each faces meet at this place, this place, they meet and form this straight line, isn't it? So this are my edges where the faces meet, and they're all together, if you look carefully, 12 edges. So in a cuboid, you have 6 faces, 8 vertices, and 12 edges. Now let us calculate the total surface area of this cuboid. We'll take this as length, breadth, and height. Okay, name the figure. Suppose A, B, C, D, E, F, G, H. Now look carefully. Area of A, B, C, D is L multiplied by H. Area of H, G, C, B, the bottom, L into B. See, there are 6 faces, isn't it? Area of F, B, C, G, B into H. Similarly, E, F, G, H, just L into H, L into H. And the topmost portion, E, F, B, A, that's length into breadth, and this face, E, A, D, H, again, that's breadth into height. So this become twice LB plus twice BH plus twice HL or LH, same thing. So 2 taken common is LB plus BH plus HL. So the total surface area of a cuboid is given as twice bracket LB plus BH plus HL, where L is the length, B is the breadth, and H is the height for this cuboid. Now, one more thing. Lateral surface area. When you talk about the lateral surface area, the area of 4 walls. Suppose in a room, I'm standing in a room, it's cuboid in shape. So the area of the 4 wall is known as lateral surface area, not the floor and the roof. Okay, area of 4 walls. So area of 4 walls, if you look carefully, it was L into H plus H into B plus again L into H plus B into H, HB. So that's twice LH plus HB, that's twice H common, L plus B, which means that is equal to twice L plus B into H. We can write as perimeter of the base multiplied by the height, isn't it? Twice L plus B into H gives you the lateral surface area, or the area of the 4 wall. 2 LH plus 2 HB. Clear? Now let us see how do you get the volume. The volume of a cuboid is given by length into breadth into height. And the most important question, how do we get this? Volume is the amount of space occupied by a solid figure. Now, before we derive this, we need to know, what do you mean by cross section? Cross section area. Now, this is a solid figure. So, if we cut this solid figure perpendicular to its length, breadth or height, then the surface exposed is known as cross section area. For example, if you cut it like this, then I think, look carefully, this portion will be exposed to us, isn't it? So this is your area of cross section. Okay, you have to make the cut perpendicular. A cut perpendicular to the length, breadth or height. Then the surface exposed is cross section area. Now, if you look at a cuboid, at any place, if you make a cut, the surface area exposed, the cross section surface area exposed is same. So this kind of solid surface where you make a cut at any point perpendicular to its length, breadth or height, you get the same area. That's known as a uniform cross section. A solid having uniform cross section area. This is a solid having a uniform cross section area, because wherever you make a cut perpendicular, of course, to length, breadth or height, you get the same area exposed. So this figure has a uniform cross section area, and any solid figure which has a uniform cross section area volume is given by area of cross section multiplied by length, breadth or height. Suppose in this case the cut is made perpendicular to the length, so it will be length. If you make a cut perpendicular to the height, then area of cross section into height. Perpendicular to the breadth, like this. Sorry, breadth will be this, height will be this. Okay, perpendicular to the breadth, it will be area of cross section into breadth. So in this case, if you see the figure which I have drawn, I have made a cut perpendicular to the length. So this area exposed will be this is your breadth and this is your height. So B into H, B into H, and it was perpendicular to the length, so into length. So the volume of this solid, which is a cuboid, is given by length into breadth into height. That's the volume. Clear? One more thing we need to know, we will discuss about the length of the diagonal or the highest or the longest rod which can fit in a cuboid. Length of the diagonal or the highest or the greatest rod which can fit in this will be root over of L square plus B square plus H square. Length of the highest greatest rod will be from this point to this point. From HB, the distance is known as the diagonal. Or you can say from D to F, E to C, A to G. If you join those 2 points, E, C, then you get the length of the diagonal, which is given by root over of L square plus B square plus H square. We can derive this by Pythagoras theorem. Okay, I'll make a video on this. Now let us discuss. So till now we have got the volume of a cuboid is length into breadth into height. The total surface area is twice LB plus BH plus HN, and the lateral surface area is perimeter into height, that's twice L plus B into H. Let us talk about a cube. So when we are talking about a cube, we are talking about a solid which is bounded by 6 square faces. When we are talking about cuboid, it was 6 rectangular faces. So the rectangular faces are replaced by square faces. It becomes a cube. You must have seen a dice, you play Ludo with that. That's a cube, that's a cube, isn't it? Suppose the side is A unit, edges, the sides are A unit. Now, just remember, suppose I'll draw a cuboid. Cuboid was like this. It has got rectangular faces. Again, over here we have 6 faces, 8 vertices and 12 edges, same as that. Now look carefully. Volume was over here length into breadth into height. So over here volume, see in from cube to cuboid, if you go, what are you doing? The length, breadth and height are becoming equal. The length, breadth and height are become equal as A. So the volume will be A into A into A. That's A cube. Done. Isn't it? We just replace length, breadth and height with A. Now total surface area was twice LB plus BH plus HL. Again, so total surface area will be twice A into A plus A into A plus A into A. That's twice A square plus A square plus A square. That's twice 3A square. That's 6A square. So the total surface area is 6A square, isn't it? lateral surface area or area of 4 walls was twice L plus B into H, remember? So again, the lateral surface area will be twice A plus A into A, that's twice, this is 2A into A, that's 4A square. And diagonal, when you talk about from here to here, the length of the longest rod which can be fit in the cube, in this cuboid, the length of the diagonal was root over of A square plus root over of L square plus B square plus H square. So we'll replace that. So it will become A square plus A square plus A square. That's 3A square. So that's root 3A square. Root 3A. That's the length of the longest rod which can be kept in a cube. Am I clear? So these are the formulas for cube. Now let us solve some sums on this chapter. Now let us solve sums from exercise 16.4 ML Aggarwal. The first sum. Find the surface area and volume for cube whose edge is 7 centimeters. So the edge is given as 7 centimeters. So we know total surface area or surface area in this case is 6A square. So that's 7 square. That's 6 multiplied by 49. 6 nines are 54. This is 294 centimeter square. Done. Very simple. Okay. Now volume. Volume will be A cube. That's 7 cube. We know 7 cube is 343 centimeter cube. So that's the volume and that's the total surface area. Now look at this, number 2. Find the surface area and volume of a rectangular solid measuring 5 meter by 4 meter by 3 meter. Also find the length of the diagonal. So length is 5 meter, breadth is 4 meter and the height is 3 meter. So when you talk about the total surface area, or the surface area is twice LB plus BH plus HL, isn't it? So twice LB, which means 5 4s are 20, BH, that's 4 3s are 12, HL, that's 5 3s are 15. So that's twice 30, 40, 47 over here. So that's 94 centimeter square. Note down this. When you talk about the volume, length into breadth into height, that's 5 into 4 into 3, that's 60 centimeter cube or meter cube, sorry. This is in meter, so it will be meter square and meter cube. Done. The total surface area and the volume. Now we'll find the diagonal. So the length of the diagonal, is given by root over of L square plus B square plus H square, which is root of 5 square plus 4 square plus 3 square. That's 25 plus 16 plus 9. That's how much? 50, I think. Just wait. 25 plus 16. Yeah, 50. So root of 50 will be 7.07 meter. Done. How do you get root of 50? See, we have done this in previous classes, 50, 7 sevens are 49, then you put a point, you put 2 0, then 14 comes. Again, it doesn't go because if you put 1 also, it will become 141 into 1, that's 141. 1 comes, so you put a 0, so 2 more zeros will come. Then if we do, see, 7 times, so instead of 49, 28, it's 9849, 7 times, isn't it? We'll do for one more place and then round up, which in this case comes as 7.07 meter. Done. Now let us look at the next sum. Now look at number 3. Pretty easy. The length, breadth and volume of a cuboid is given. You need to find the height. Very easy. We know volume equals to length multiplied by breadth multiplied by height. So height will be volume by L into B. it will be 7,000 by L is how much? 25 multiplied by 20. So that's now 2 1 times 2, 3, 50 times. Now this is 14 times, isn't it? So the height will be 14 centimeter. Pretty easy. Look at number 4. A classroom is 10 meter long, 6 meter broad, and 4 meter high. How many students can it accommodate if one student needs 1.5 meters square of the floor area? How many cubic meter of air will each student have? First of all, area of floor will be length into breadth, isn't it? If you imagine a cuboid, the floor has length and breadth. It's rectangular. So length into breadth, that's 10 into 6, that's 60 meters square. So one child occupies 1.5 meters square. So number of students will be the area occupied by each student, isn't it? So it's 40. So how many students are there? There are 40 students in the class. Okay. Now the second part. How many cubic meters of air will each student get? Now volume is length into breadth into height. That's 10 into 6 into 4 meter cube. This is the volume, total volume of the class. Okay. Now what they're asking? How much air will each student get? So volume of air each student get will be the total volume divided by the number of students. That's 40. So that's 6 meter cube. So 6 meter cube of air will be available for each student. Clear? Pretty easy. Now let us look at the next sum. Now look at 5 part A. The volume of a cuboid, the volume is given as 1440 centimeter cube. The height is given as 10 centimeter. Okay. And they have told, and the cross section is a square. Cross section is a square. Imagine a cuboid whose base is a square, which means nothing but the length and the breadth is same. Suppose A. Okay. Now find the side of the square. Very easy. See, volume equals to length into breadth into height. So volume is 1440. Instead of length, I can write A. Again, the base, breadth, I can write A into height. That's 10. So that's A square is 144. So A is root 144. That's 12 centimeter. Which means the side of the square is 12 centimeter. Pretty easy, isn't it? Number 5 part B. The perimeter of one face of a cube is 20 centimeter. Find the surface area and the volume of the cube. The perimeter of one face is given, which means side will be P by 4. That's 20 by 4. That's 5 centimeter, isn't it? Once you get the side as 5 centimeter, we know the TSA is 6A square, which is 6 into 5 square, which is 6 into 25. That's 150 centimeter square. And the volume is A cube. That's 5 cube. That's 125 centimeter cube. Done. Pretty easy. From the perimeter, we got the side. Once you got the side of the edge, you can get TSA and volume by simply substituting the value in the formula. Clear? So in this video, keep it till here. In the next video, we'll see the rest of the sum. Till then, take care.